to show the grand average curve obtained with its procedure was very close to a Gaussian. In order to investigate whether calibrated and non-calibrated estimation rely on fundamentally different mechanisms, in this model, sensitivity was measured by the internal Weber function, which gives the amount of noise in the representations of numerosity. Response bias are captured by the parameters of the phi transformation imposed on the response grid. The values of these parameters were estimated for each participant, and each of the two experimental sessions, and we examine whether these parameters vary in a systematic way between groups of participants. Through the ANOVA analysis, we can not measure a significant benefit of inducer in each of the dependent variables. Next, the two-way ANOVA analysis revealed a significant benefit of session in parameter A and B, but there's no significant benefit of value of inducer in each of the dependent variables. But there's an interaction of session by value of inducer in parameter B. So we can observe a high level of correlation between the values of internal Weber function A and B for the two sessions across participants. To the discussion, first, this model relies on three classical hypotheses. First, numerosities are encoded on a number line. Second, the scale of this internal number line is logarithmic. Third, for a given numerosity, the dispersion of activations on the number line follows a Gaussian distribution. The two hypotheses have been aided to account for the need to give numerical responses in estimation tasks. First, number words are associated to segments of the number line, thus defining a response grid. Second, responses can be calibrated by applying a transformation to this response grid. When the response grid needs to be calibrated, the participant applies a phi transformation to its spontaneous response grid. The model is a good predictor of several aspects of the data because the shape of the mean response function and the dispersion of the responses around the mean, which follows scalar variability. Reconstruct the distribution of activities on the number line from the responses to this numerosity estimation task and prove that the activation curves are Gaussian, as it is postulated in the model. The model incorporates several parameters which could serve to underlie calibration process, such as internal Weber function, parameter A and parameter B. When the participants are presented with a new value of inducer and need to recalibrate their responses, the intrinsic variability of the internal continuum, which is sensitivity, remains constant, while the stimulus response mapping is shifted dynamically to fit the new inducer value. The internal Weber function is slightly higher than the previous estimation. Here are several reasons. First, receiving feedback may help participants identify the influence of low-level continuous parameters by a similar estimation. Now, the other is previous researchers did not always control for numeric confounds, and the participants may have used these confounds to improve their performance. The difference with this estimation, which is 0.22, may result from the fact that feedback was given on each trial in their experiments. The present study and experimental results provide important tools which in the future could be used to explore the interface between verbal and nonverbal numerical cognition. For instance, in brain lesion, dyscalculic patients or in young children who require more abilities to solve mathematical problems.